Good afternoon. So today we are going to be on page 78 to begin. We are going to be using the topic of exponents, which is the first thing that we're going to learn about in Unit 3, which is covering exponents and expressions. We talked briefly in the last section about vocab, about exponents, and that they have a base and an exponent. We are going to be using them today and learning some of the rules that will help us to be able to apply them as we study expressions. Your topic, like I said, is exponents. Your essential question, which you should be able to answer by the time you are done with these notes, is what is an exponent and how do I solve them? This comes from Standard 6 EE1, which is 6 Exponents and Expressions 1. By the time you are done with this standard, you know you're proficient if you can write and evaluate numerical expressions involving exponents. For our notes today, I want us to understand that that term exponents is vitally important. So every time you see it, I want you to box it in. You don't have to use a different color. I like to because then it really makes it pop out. But that important term, whenever you see it, I want you to box it. Now, you'll notice I have this number 2 to the third power, and I'm going to color it into 2 different colors so that it's really clear that these are 2 different terms, and I can make sure I know what I'm supposed to do with them. Like I said, you could shade one and leave one white. You could do a pattern on one. You don't even have to color it. I just like to do it because I think it makes it look a lot clearer when I'm going back to these notes. And the first thing you need to know is that big number 2, the bottom number. We call that the base. It is the number that is going to be multiplied by itself. And we will know how many times we multiply it by ourselves based upon this small number up above, this little 3. And this is called the exponent. Once again, we saw the word exponent, so we're going to box it. Exponents are oftentimes also called powers. So we would say 2 to the third power. Now, some people get confused when they see this type of a problem and they think, oh, this means 2 times 3. It, however, does not. It's slightly different. It actually means you're multiplying the base of 2 3 times, or you're doing 2 times 2 times 2. So 2 to the third means 2 times 2 times 2. Well, let's do that together, class. What is 2 times 2?
4.
Times 2?
8.
So 2 to the third power would equal 8. Not what sometimes is confused, 2 times 3, what is 2 times 3, class?
6.
That's obviously not the same thing. So do not ever, when you see an exponent, that little number that's raised, don't ever multiply it by the base. Always take the base and multiply that base by itself, however many times the exponent tells you. So let's look at our definition that is presented below. Make it expand a little bit. And it says the base needs to be multiplied by itself as many times as the exponent says. We have exponent, and I just want to show that that is this number, and the base is that number. All right. So there are some other rules that we need to remember. The first rule is anything to the 0 power. Whenever you see something like 3 to the 0 power, 1 to the 0 power, basically you need to remember the rule that that equals 1. And the reason that happens is if I would have 2 to the second power, I would have 2 times 2. If I were to have 2 to the third power, I would have 2 times 2 times 2. And so forth. 2 to the fourth power, 2 times 2 times 2 times 2. If I'm following this pattern, 2 to the 1 power, if you notice every time I go up, I remove a 2, a base from it. Well, then what would I be left with here, guys? If this is 2 to the fourth power, and there's 4 2's, this is 2 to the third power, and there's 3 2's, this is 2 to the second power, and there's 2, what would I be left with here for 2 to the first power?
2.
1, 2. Notice the pattern. Now here's where it gets tricky. If I have 2 to the 0 power, I'm not left with anything, but I am, because there is a hidden mystery number in there. And that hidden mystery number is every time I have this, I'm actually also multiplying it by the number 1. Now that doesn't make a big difference, because if I have 2 times 2, that's 4. 4 times 1 is going to be 4, because any number multiplied by 1 is itself. Where it makes a difference is if I'm left over here with no 2's, I'm only left with 1. So it ends up being a part of this value. That any number multiplied to the 0 power is going to be the number 1, because it's what's left over. So let's practice that. 3 to the 0 power is what, class? 1. 10 to the 0 power?
1.
1,000 to the 0 power?
1.
Anything to the 0 power is 1. Some key terms that we need to understand as well. Squared. Squaring a number is any number to the second power. Or, like 2 squared, looks like this. Alright, and then we have cubed. Cubed is any number to the third power. Or it would look like this, 2 cubed. Alright, let's look at this example that we get. X to the fourth power, using the variable value that x equals 3. So you would have x to the fourth. We're going to plug in the variable. And now this is called the exponent form. We're going to write it now in the extended form. The extended form would be 3 times 3, the base, 4 times. 3 times 3 times 3 times 3. This is called the expanded form. Now, to solve this, guys, it seems confusing. 3 times 3, that's 9. 9 times 3 is 27. 27 times 3, then I have to kind of like write it out because I have a hard time doing that in my head. But there is a quicker way of doing this, guys. Check this out. What is 3 times 3?
9.
And we have a 3 times 3 over here too, right?
Yes.
What's 9 times 9?
18.
9 times 9?
81. Oh, 81.
81. That is your answer. So when you do this, you can actually put your products or your factors together in order to make it simpler to do. All right. On page 77, you're going to do the examples that are presented on page 77 on your own. Thank you very much, and have a fantastic day.